All right, so back to statistics. Something I just want to point out, most common problems people have in playing with statistics are distinguishing between or and in a given situation, the idea about an intersection, and then with the and, the idea that this new knowledge changes everything. And there is a relationship, right, between and like, let's say the probability I tested positive for COVID and I actually have COVID versus the probability that I tested positive for COVID, but I already knew I had COVID. So those are two different questions, two different probabilities, but they are related through this formula. And we're gonna look at how they're related in the two-way table next. And again, the more experience one has with this kind of situation, the easier it is to think about it. But the bottom line is it's always hard to think about it. It's complicated. It's multidimensional. All right, so here is the spreadsheet we're going to start playing with here. And feel free to make a copy of it or just kind of follow along here. So what I want to do is just say I have a sample of information about tests that we're doing for COVID and whether somebody actually had COVID or not. So whenever some kind of drug manufacturer makes a test for a given disease, whether it's influenza, COVID, colon cancer, you name it, they've got to run through all these tests to try and figure out how accurate is the test. There's all this terminology related to the accuracy of a test. So I just want to go over a little bit with that terminology and how it relates to probability. So let's suppose we had this data about a test and I have 285 people that had COVID and tested positive, right? So and is when a row and a column intersect. I have 15 people that had COVID, but they tested negative. I have 70 people that did not have COVID and they tested positive. And I have 630 people that did not have COVID and they tested negative. Right, so this would be a good result there. They didn't have COVID, the test was negative, that's a true negative. Up here, the 255, they did have COVID, they tested positive, that's what we call a true positive. So I'm just gonna make a little comment on that there. So this right here is what we call a true positive. And then here, they didn't have COVID, we know that. We gave them a test, the test came on negative, that's what we want to see, they're negative for COVID, so that would be a true negative. So just have a little comment on that for now. True negative test. Comment. Now, to do some probabilities, I need some totals. So I need to add up how many people had COVID, how many people didn't, how many people tested positive, how many didn't. And the ideal way to do that in a spreadsheet is you pick the cell you want the total to be. Total here, so I know what the numbers mean when I look back at it tomorrow. And the formula is equals SUM for sum. And then I just select the numbers I want to sum with my mouse, close the parentheses. Notice I put a colon in between them. That just means start at B4 and end at B5, which is fine. All right, 300 there. Same thing here, equals sum, parentheses, or select it, highlight, close parentheses, enter. And we'll do totals here for people that took the tests. So again, sum formula, and I could have just put a plus between them, but the sum is really the better way to do things on a spreadsheet. And so I just want to highlight them. Ooh. Whoa, did I mess that up? My mouse is out of control. Oh, I think it's because that box keeps popping up on me. Google, come on, stop messing with me. All right, I think I got it that time. Huh. How can I do this today? Finally. Those comments, I think, were getting in the way. Now, to get what we want is, these are subtotals really here and here. to get the total of everything, I can either add up this column, add up this row, or add up the original 4 numbers. And so it doesn't really matter which way you do it. I'm gonna add all of them. To do that, I would just take sum and then highlight over and down. I should have 1,000. And then I usually kind of like to double check. Do these 2 numbers add up to 1,000 also? So sometimes just to make sure I didn't mess up my table, I'm going to do some checks off to the side and then delete them after. Yep, those 2 add up to 1,000 also. Do these 2 add up to 1,000? I can pretty clearly see they do, so I'm not going to do it there. And then let's maybe shade these guys to make it prettier, make those stand out. Totals. All right, so I just want to go back to the idea of like a true positive and a true negative. True positive. What does that mean in probability? So true positive means they tested positive and we know they have COVID. If we know they have COVID, sorry, I'm messing up on a mistake, and versus if. So probability of having a positive test if they have COVID. In this case, that would be, and again, think about our formula. Let's write this down. Probability someone had a positive test if we know they have COVID. This is what's called true positive. And that would be the probability they tested positive and have COVID. Divided by the probability one has COVID. And remember the if, I prefer to say knowing, right? We have this new knowledge. So what's the probability to test positive when we know they have COVID? So when I think about it that way, looking at the table here, I know they have COVID, so I'm only concerned about that column right there. So I want to know what are the positives out of the people that have COVID. So I would just simply grab the positive people here that had COVID and divide by the people that have COVID. So this is a true positive, it's 95%. This is what's called the sensitivity of the test when they're researching how good a test is. Okay, so this test is highly sensitive. Look at true negative. So true negative is the probability that they tested negative if there's no COVID. That's a good thing, it's true. Notice I'm kind of exceeding the edge of my cell here, so I can just click at the boundary here and drag it to be a little bigger, or sometimes double clicking will make it just the right size. All right, so if, right, knowing. So what's the probability they tested negative, knowing they do not have COVID? So I'm only focused on the people that don't have COVID and the negative tests. So that would be the 630 out of the 700. So I can just down here go equals, click on the 630. And just a note, when you're working in a spreadsheet and you want to do a calculation, if the number is on the screen, don't type it because you could mistype it. Just click on it. So equals, click on the number, slash to divide, enter. So here I get 0.9 or 90%. So we could reformat those as percents if we want by just highlighting them, click the percent button, and I don't need those decimals. This right here is called the specificity of a test. Do you need to know that? Is it going to be on the test? No, but this is language that comes up when doctors and nurses are looking at the results of a test. They have to analyze, hey, what does this test really mean from the lab? And those are two things that the FDA wants to know about a test when a manufacturer says, hey, okay, doctors, you can use this test now. Hospital, you can use this test. They got to come up with all this data. And it's hard to come up with because the test gives us some information, but is it correct? Sometimes things come out wrong for all kinds of reasons. So true positives and true negatives are important. Those are measurements that are used often by FDA, by companies that make these tests, by doctors. Other things that are important is sometimes you have a test and it's wrong. My daughter had COVID a few weeks ago. I was sure I had the same symptoms as her. I went and got tested. It was negative. But I was sure I had the symptoms, that I sure I had COVID. The test is wrong, right? Was my test a false negative? I don't really know, right? So the idea of a false positive and a false negative, so those ideas. False positive. And I'm going to write this down in some human language before I get to the language of statistics. What is false positive? So false positive means we got the test said they were positive, but it's wrong, right? We know they really don't have it, right? So it's the probability of getting a positive test knowing they really don't have the disease. Disease. There we go. Oh, so my test did come back negative twice. I had it tested 2 weeks in a row. My daughter's test did come back positive. She definitely had COVID. And the COVID testing, my recollection is it's about 95% sensitivity, meaning 95% of 95% of people with COVID will test positive. For false negatives, for true negatives, that's the specificity of the test. I always have to look those up. I think for a lot of the COVID tests, like the good nasal swab ones, I think it's around 80%, meaning that if we knew you didn't have it, 80% of the time, the test will say you don't have it. All right, so back to false positives here. Probability of getting a positive test knowing they really don't have it. So if we put that in probability notation, it's the probability of ending up with a positive test, but it was wrong. So if they really don't have it, so no COVID in this case for the test. So to calculate the false positive rate, I look at only the people that have no COVID. So let's go do that. So false positive, let's put the notation, that would be the, oops, I'm gonna click in the cell, I guess. Probability of getting a positive test if no COVID. And so again, no COVID is all I care about, right? But they tested positive. Oops. So equals, in the COVID column, they tested positive out of all the COVID cases. Right? And that's just called false positive. And so if this data is correct, then there's a 10% false positive rate. False negative, similar. So that would be the probability that they tested negative, but they actually have COVID, right? If the negative test was wrong. So if they actually have COVID. So the negative test, it's false, they really had it, oops, right? We don't like that false part there, but it happens. So think about this, now we only care about the COVID people, so I only focus on the COVID people and the ones that got the wrong test results. Oops, 15 out of 300. And again, equals, click on the 15, divide by, click on the 300. I almost typed it. And that is 5% false negative rate. So notice these are related, but they're like not add subtract related. So the true positive is 95% and the false positive is 10%. The true negative was 90%, but the false negative was 5%. Okay, so they're related, but they don't directly add up because this is a complicated table. There's lots of information going on right there. We have 4 separate cells in the middle. We have multiple subtotals we can make, and we have the total in the whole population there. There are a couple other pieces of terminology, but I think I don't want to go over that right now. I'm just going to do one more example, but from a different direction. So sometimes with COVID, with any kind of testing, if you look up data on it, information that you'll be given about testing is you won't necessarily get all of that information. So about disease testing and probabilities. They'll either talk about the prevalence rates, or sometimes they're going to talk about the incidence rate, and those are easily confused. I have to look it up to double check I know what I'm talking about every time I discuss this with people. So prevalence is how many total cases are going on in the population. So total case rate. Versus incidence is only the new cases in some time period. New case rate. And sometimes when I look up data about disease testing, they talk about the incidence rate and the false positives and false negatives. And other times they talk about the prevalence rate and the false positives and false negatives. And I haven't figured out yet why they pick one over the other. So apparently I need more education in that. But it can be either way. So sometimes you see reference to incidence rates, sometimes you'll see reference to prevalence rates. And I don't know why they jump between them because they are definitely 2 different things. Like the incidence rate for COVID, I think is about 0.1%. Whereas right now, the prevalence rate for COVID, I think is somewhere between like 10 and 30%, depending on how you count it. And a lot of it depends on what you consider the time period. Is the time period of consideration new cases this week, or new cases this month, or new cases this year? And that those time periods do fluctuate depending on how someone's referencing this. So prevalence or incidence, but it's basically how much of the disease is in the population. So if we look back at the table we have here, and I wanted to look at the prevalence rate, spot, I'm gonna put it up here. I would take the total number of COVID cases, that would be 300, and divide by the total population that I have at the moment. And I have 1,000 in my population. So the prevalence rate here would be 300 divided by 1,000. So here I'm using a 30% prevalence rate. Okay. Is that appropriate? And again, it depends on the situation. What is the prevalence rate? And it might change from region to region. Okay. Like the prevalence rate in Multnomah County is probably going to be higher than the prevalence rate in Umatilla County, maybe because of the population density. But there's many other factors too, like do people really wear masks? Do people social distance? So it's complicated. All right, so that's prevalence. So the prevalence rate I'm using here is 30%. So we got to have a prevalence rate or have some numbers given to be able to talk about disease testing. And then other things we need either some combination, either a number of true positives true negatives, false positives, false negatives. In order to answer like all possible questions about testing, we need at least 2 of these. And so, like I said, sometimes when I look up data on testing, they'll give me the incidence rate and the true positives and true negatives, and I can figure everything else out. Other times they're going to give me the false positives and the false negatives and the incidence rate, and then I can figure everything else out. So I'm just going to go over a scenario where I'm given that. So let's go with this scenario. That we're going to have a prevalence rate of 10%. And let's go with false positive rate of 5% and a false negative rate of 10%. And that's a little different than what we did before. And so we're going to whip that out on a spreadsheet. So to do that, let's see, is the next tab ready to go on that? Not that one. That one. And not that one. Okay, we're just going to make a new one then. So let's say this is COVID testing again, so I'll just label at the top, COVID testing. And if you want to get into this spreadsheet and you lost track of it, I can put the link in, again, the chat, just in case. It's the same spreadsheet, new tab. And if you're on YouTube, this link should be in the description. Pretty good about putting those in there. And then over here, we'll have the truth of, the situation. So either the truth is you got COVID or there's no COVID. And then either the test came back positive or the test came back negative. And we have totals. And if we don't want to end up with decimal numbers of people, then we have to pick a pretty big starting number. So just to be safe here, I'm going to start with 100,000 people. And I usually like to put commas on those. I'm just going to reformat that as a number and then get rid of the decimals. So starting with 100,000 people. And so here's my given information. I've got prevalence. You can just type 10%. I've got false positive of 5%, and false negative rates of 10%. So suppose those are the stats we have about the particular test we're looking at. So the first thing we have to do to fill out this table is figure out, okay, well, how many people actually have the disease? So that's where I use the prevalence rate. And the prevalence rate is just people with the disease. People, all people. Ooh, that's nice for people. So out of this 100,000, how many actually have COVID? So I'm just going to highlight these two cells to indicate my calculation here. So I want to know what's 10% of that 1,000. So I'm just going to go here and type equals. Ooh, wrong cell. I'm going to go over here and type equals. And then I want to know what is 10% times that 100,000. Again, it'd be nice if that had commas so I don't mess it up. No decimal. Okay, so 10,000 people would be 10% of 100,000. Okay, so now I know how many people have COVID. I can just subtract to figure out how many people don't have COVID. So equals, out of this 100,000, take away the people with COVID, so that gives me 90,000. Once I know the people who have COVID and not COVID, I can think about the false positive and false negative. So let's remind ourselves what false positive means. So false positive is the probability that you got a positive test if it's wrong. Okay, so it said I had COVID, but I don't. So if no COVID. Think about that again. Test came out positive, but it's wrong. If it's wrong, I don't have COVID, but they said I did, but I don't. All right, so here, the if tells me I only care about the no COVIDs. I want to know what's 5% of those. that tested positive. So that would be this cell right here. They don't have COVID, but they tested positive. So let's highlight that, just to be clear, and that. Okay, so I want to know what is that 5% false positive rate of all the people that don't have COVID. So multiply, multiply. All right, so that would be 4,500 out of 90,000 is 5%. And then the false negatives are next. Highlight that. What's a false negative? Think about it. Okay, so the test came back negative. So what's the probability of getting a negative test, but it's wrong? So they said I don't have COVID, that means I do. So I actually have COVID. All right, so the if says you only care about the COVIDs, so only in this column, but you tested negative. That cell right there. All right, so then it equals what is 10% times this 10,000 here, right? Only COVID people, and I get that number. Now to fill in the rest, I just have to do some adding and subtracting. So there's 10,000 people in this column, I can just subtract to get that number. So it's 10,000 minus 1,000. And then here, subtraction, what is 90,000 minus those 4,500. And then I can get my subtotals if I need them by just doing my sums. So given a few pieces of information, prevalence in particular, and then either information about false positives, false negatives, true positives, true negatives, I can then answer any question anybody asks me about this disease test. So we have time for one more question before we depart. All right, so there's all my information. Again, double checks would be, do my totals really come out here? Do these totals really come out to 100,000? This one I can plainly see. This one I'm going to double check. So I'm just going to go off to the side here and do a sum. Do these really add up? Yep, they do. Okay. All right, so what I want to know is, okay, I went and got a test the other day, it was negative. What's the probability it's a true negative? So let's look for a true negative. So let's say true negative. So that would be the probability the test came back negative, but and it's really right. So if I really have no COVID, that would be a true negative. So to calculate a true negative here, I just say, okay, focus on the no COVIDs. So that's this column. And then those that actually had a correct test, which would be this 85 right there. So I'm focusing on this column to answer this question. So equals negative and didn't have COVID, that number, divided by all the people that had COVID. So there's a 95% chance. So if this were the data about the test I was taking a couple weeks ago, there was a 95% chance my test was correct. That if we knew I didn't have COVID, the test was negative. Now I could answer the question the other way. What's the probability that I definitely know I don't have COVID? I go and get a test. What's the probability it really says, hey, you don't have COVID? Okay, that is actually called something else. What is it? A negative predictive value, but it's a different question. What's the probability? I don't have COVID, so I walk in saying, I'm sure I don't have COVID. Absolutely no, I don't. If I get a negative test. In this case, I'm only focusing on the negative tests. Let's make that a little bigger. So the if is my new knowledge. So that's this row right here. And I only look at the no COVIDs with the negative test. So equals on this row, no COVID and test negative. That's the same 85,000 I clicked here. But this time I'm dividing by all the people that tested negative. And that is a much different number. That's 0.988, 98.8%. Okay, if I know my test is negative, I don't have COVID. This one, if I know I don't have COVID, what's the probability of getting a negative test? So two different things. This one right here is a true negative test. This one right down here, I believe, is called the negative predictive value. I think they call it the NPV for a test. Doctors are usually concerned about that number too. All right. Oof, this stuff is mind-blowing. It takes time to get used to. But it is time to stop. But one more note before